Hello, dear students. This is Dr. Sourav sir's class. We are now solving our UPSC mathematics exam questions, which appeared in our 2024. Now we are doing is question on our sequence series of function. So the question says us to consider the series this, that is our n equals to 1 to infinity unx, and our x running from 0 to 1, the sum of whose first n terms is given by, let me change my color first. So the first n term sum is my, yeah, okay. Let me wipe up, please. Okay, now, yeah. Then log of what? Okay. So now, so that the given series can be differentiated term by term, though the series u dash nx does not converge uniformly on 0 to 1. Open, on close 0 to 1. Now, what can be done? We aim to analyze the series this, our partial sum is our this. Now we have to find the terms of the series unx. So the nth term of this, that means unx, is equals to our snx minus of sn minus 1x. So that will be what? We have to put the values, and we have to put n minus 1 in the position of n is this part. So we get, yeah. Then what will happen? Okay, leave it. Now, firstly, we are going to differentiate our SNs. So we first compute our, yeah, we have to compute first del SNx by del x, which will be what? Which will be my 1 by 2 n square will be constant, so it will come outside, and our del x of, yeah, of log, yeah. So we are using chain rule here for the partial differentiation with respect to x. We will get this thing. The differentiation derivative of log is our 1 by the function. So it is our this, and inside, for the sake of chain rule, we will get this. Now what is the value of that? Yeah. Now it will be my 2 n to the power of x. Okay, then our 2n square and 2, this will cancel out. So this is my result. Now what will happen? Now we have to do the term by term differentiation. We have to check that occur or not. The derivative of the nth term, the derivative of the nth term un dash x is our del u del x Yeah. So we are gonna using the result from step 2. So we will get our step 2 has this result. So we are gonna use it. Then what we will get? Then we will get. Okay. First, we have to rewrite this as this. And in this case, n minus 1 will put it in our position of n. Yeah, that is 2. And it will my this. Then we have to check for uniform convergence of the series or derivative series. Okay. So now we have to check the uniform convergence of our summation n equals to 1 to infinity u n dash x. Now we examine the term our u n dash x, which is equals to our n square x by this. Now for x equals to 0, for our x equals to 0, u n dash x is equals to 0 and the series trivially converges. Okay, now for our x not equals to 0, what will happen? We have to check that. So the term our n square x by 1 plus n to the power 4 x square behaves asymptotically as this for very large n. Now, as n tends to infinity, our u n dash x goes to 0. That point to be noted that it is pointwise. It is pointwise for any fixed x greater than 0. Okay. However, the rate of the decay depends on x, and for small x, the term u n dash x become arbitrarily large for large n, preventing that uniform convergence. Now we have to verify that the series this diverges. This diverges. To check the divergence, observe that the growth of this n equals to 1 to infinity our n square x by this, then for small x, what will happen is, yeah, so the term behaves like our n square x, then it will leading to the divergence of the series. So what the conclusion are bringing out from the question, the series summation of n equals to 1 to infinity, that means this series is can be differentiated term by term because our Sn x is differentiable and our unx is smooth. This is smooth. Now the series our un dash x, sorry, yeah, the series un dash x does not converge not uniformly on close 0 1 as the term un dash x growth grows unboundedly for small eggs. Yeah, that's our required answer for the given question. Hope you are studying well for your upcoming examinations. Okay, thank you guys.